Ever pondered how vast our universe truly is? Let's take a moment to marvel at the sheer size of our cosmos. The universe, mind you, is not just the tiny, observable portion we've managed to study. It's a colossal expanse, so large that our human minds struggle to grasp its scale. Scientists have estimated the observable universe to be about 93 billion light-years in diameter. That's just the observable part, mind. The universe beyond our sight could be infinitely larger, or perhaps even infinite itself. Now, you might be asking, what exactly is a light year? It's not a measure of time, as the name might suggest, but a measure of distance. A light year is the distance that light, zipping along at a whopping 186,282 miles per second, can travel in a year. That comes out to nearly 6 trillion miles. That's a 6 followed by 12 zeros, if you're curious. Let's bring it a bit closer to home. Even our own galaxy, the Milky Way, which is just one among billions, is 100,000 light years across. That's right, 100,000 times 6 trillion miles. Our tiny planet Earth is but a minute speck in this vast cosmic expanse. Consider this for a moment. When you look up at the night sky, you're seeing only a fraction of our own galaxy. The countless stars you see are just our closest neighbors in the grand cosmic scheme. Each one of those pinpricks of light could be home to its own system of planets, perhaps even life. And beyond our galaxy, there are countless more galaxies, each with their own stars, planets, and potential life forms scattered across the universe. So the next time you gaze up at the stars, remember this: our universe is unimaginably vast. We are but tiny, fleeting blips in the grand cosmic dance. And yet, here we are, pondering the universe and our place within it. In the grand scheme of things, our planet is but a speck in the cosmic ocean. Did you know the universe is not static, but continually expanding? It's a concept that boggles the mind, isn't it? This idea springs from the Big Bang theory, the prevailing cosmological model that suggests our universe has been expanding since its birth about 13.8 billion years ago. That's right, the universe wasn't always as massive as it is now, and it won't stop growing anytime soon. Now let's talk about Hubble's law. Named after the great astronomer Edwin Hubble, this law tells us that galaxies are moving away from each other at a speed proportional to their distance. Imagine a loaf of raisin bread baking in the oven. As the dough expands, the raisins move farther apart. That's essentially what's happening in our universe. Galaxies are the raisins, and space is the dough. So not only is our universe vast, but it's also growing every second. Have you ever wondered how old the universe is? Well, it's not just a few million or even a billion years old. Scientists estimate the universe to be approximately 13.8 billion years old, give or take a few million years. That's a lot of birthday candles. But how can we possibly know the age of something as vast and complex as the universe? It's all thanks to the cosmic microwave background radiation, or CMB for short. This radiation is a remnant of the Big Bang, and it permeates all of space. By studying the CMB, scientists can estimate the age of the universe. The CMB is a bit like the universe's birth certificate. It's a snapshot of the universe just a few 100,000 years after its birth, giving us valuable clues about its age and evolution. So, let's take a moment to appreciate this. Our universe has been around for a long, long time, and it's still evolving. Is our universe the only one out there? This question, once the domain of science fiction, has now entered the realm of serious scientific debate. The answer lies in the exciting yet controversial multiverse theory. The multiverse theory, as the name suggests, proposes the existence of multiple, even potentially infinite universes. This isn't just a simple multiplication of our own universe, but rather an infinite variety of universes, each with distinct physical laws and properties. Some might be strikingly similar to our own, while others might be radically different, with variations in fundamental constants or even dimensions. Imagine a universe where gravity is stronger or weaker, or where the speed of light is not a constant. Imagine a universe where time runs backward, or where space is not three-dimensional. These are not just fanciful musings, but real possibilities under the multiverse theory. But where do these other universes exist? They might be right next to us, but in a different dimension, like pages in a book. Or they could be far away, beyond our visible universe, in regions we can never reach, even if we traveled at the speed of light forever. The multiverse theory also offers a possible answer to why our universe is so finely tuned for life. With an infinite number of universes, it's not surprising that at least one of them, ours, has the right conditions for life to exist. This is known as the anthropic principle, the idea that our universe appears to be designed for us because we could only exist in a universe that allows for our existence. Of course, the multiverse theory is not without its critics. It's still a hypothesis, not a proven fact. But it's a hypothesis that's gaining traction in the scientific community, and one that could revolutionize our understanding of reality. The possibility of multiple universes opens up even more mind-boggling prospects. It's a thrilling thought, isn't it? As we continue to explore and understand our universe, we may discover that it's just one of many in a grand cosmic ensemble. What if we told you that we can only see about 5% of the universe? Yes, you heard it right. The vast majority of the universe, about 95%, is made up of something we can't even see or touch. These elusive substances are known as dark matter and dark energy. Now, don't let the term dark mislead you. It's not dark because it's some spooky, sinister force lurking in the shadows. No, it's dark because it doesn't interact with light or any other form of electromagnetic radiation. We can't see it, we can't feel it, but it's there, and it's everywhere. Let's start with dark matter. It's a kind of matter that we can't directly observe, but we know it exists because of the gravitational pull it exerts on visible matter. Without dark matter, galaxies would fly apart, unable to hold themselves together. It's like the unseen glue that holds the universe together. And then there's dark energy. While dark matter pulls things together, dark energy does the opposite. It's pushing the universe apart, causing it to expand at an ever-accelerating rate. It's a bit like an invisible rubber band, stretching the fabric of space-time itself. But here's the real kicker. We don't know what dark matter and dark energy are made of. They're the greatest mysteries in cosmology, the elusive enigmas that scientists are striving to solve. We're standing at the edge of a vast cosmic ocean, peering into the unknown, and trying to decipher the secrets of the universe hidden in the darkness. So the next time you gaze up at the starry sky, remember, for every twinkling star you see, there's an unimaginable amount of dark matter and dark energy out there, unseen and unfelt. We live in a universe where the known and the visible are just the tip of the cosmic iceberg. There's much more to our universe than meets the eye. What does the future hold for our universe? An intriguing question, isn't it? As we stand on this tiny blue dot we call home, gazing up at the cosmos, we can't help but wonder about the ultimate destiny of the universe. There are three main theories that cosmologists have put forth: the Big Freeze, the Big Rip, and the Big Crunch. Let's start with the Big Freeze. This theory suggests that as the universe continues to expand, it will eventually spread matter so thin that stars will no longer be able to form. Energy will be exhausted, and the universe will become a dark, desolate expanse of nothingness, frozen in time. Quite a chilling prospect, don't you think? Next, we have the Big Rip scenario. Imagine, if you will, the universe's expansion not only continuing but accelerating. This would stretch the fabric of the universe to its limits, tearing apart galaxies, stars, planets, and even atoms themselves. It is a dramatic end, akin to a cosmic unraveling of everything we know. Lastly, there's the Big Crunch. This theory is somewhat the reverse of the Big Bang. It proposes that the universe's expansion could slow down and reverse, causing everything to contract back into a singularity. Essentially, it's a cosmic rewind button, potentially leading to another Big Bang and a new universe. Each of these theories presents a different, equally fascinating outcome for our universe. Will it freeze, rip apart, or crunch back into itself? We don't know. The universe keeps its secrets well. Researchers continue to study and gather evidence, hoping to unlock these cosmic mysteries. The universe's fate remains uncertain, but one thing's for sure: it's a fascinating place to explore. Whether we're talking about the vastness of its expanse, the mystery of its origins, or the enigma of its future, the universe never ceases to captivate us with its sheer wonder and grandeur.